So this is the area where there's been a lot of exciting developments over the past few years. And I'm going to talk about treatment strategies for Leber's optic neuropathy and the progress that has been made, but certainly there's a lot of challenges left ahead of us, and we need to think hard about how we can pull forces together to make further advances in this field of research. And one of the things about Leber's optic neuropathy, and that's actually one of the work that I did as an undergraduate with Professor Turnbull and Professor Chinry when I was just starting in this area of research, we look at the epidemiology of Leber's optic neuropathy in the north of England. So for those of you who don't really know where Newcastle is here in the northeast, very close to Scotland. So if Scotland becomes independent in September, I will be a border town, right? But I don't think there will be any skirmishes. So the bottom line here is that LHON is the most common mitochondrial genetic disorder in the population. And the minimum prevalence in the UK is 1 in 31,000. So it is rare, but not that rare. The terrible thing about this disorder is the visual prognosis is pretty dismal because significant visual recovery is rare, and even if it does occur, it tends to be partial. And as a lot of people in the audience will know, the best visual prognosis is with a 14484 mutation. And in terms of the impact of this disease on patients that are unfortunate to be affected, it affects predominantly young adult men who are otherwise fit and well in themselves. And you can imagine how this will have a significant impact on someone's quality of life. And we've heard these amazing stories this morning of patients who've gone through this whole process and have done their best to cope with their visual handicap. So what about treatment? What can we clinicians offer our patients that have been affected with this condition? Well, the first point to make is that treatment options still remain limited for Leber's optic neuropathy. And because treatment options are limited, we need to actually focus on supportive measures. So genetic counseling is very important because people need to be aware about whether or not they have a risk of transmitting the mutation to the next generation. Patients need to be provided with access to low visual aids. And also they need to be supported in terms of occupational rehabilitation because as we've heard this morning, a lot of patients, after a period of difficulty coping with the loss of vision, will then move on and get on with their lives and carry on working and be active members of society. And things are much easier because of social media and the work that Lisa and other people in the UK where I come from are doing, setting up these patient networks, allowing people to share their experiences, which makes it much easier to cope when you're faced with this really kind of depressing situation of losing your vision very quickly, when before then you were otherwise fit and well. So the support network is very important, and what I want to do now is focus more on the research side of things. What can we do to try and preserve these retinal ganglion cells, to try and preserve vision? The dream, of course, is to prevent visual loss to take place in the first place, but we're not there yet. So I think we're talking more in terms of preservation of vision. So I'm going to talk about the use of mitochondrial antioxidants. Valerio has mentioned this already in terms of activation of mitochondrial biogenesis in unaffected carriers. I think it's also important to cover unproven therapies that people and their families can come across on Google and various other websites because there's a lot of myths out there that needs to be debunked. I'm also going to talk about gene therapy, which is a very exciting new development in terms of treatment for this disorder. And finally, because I'm based in Newcastle, I will also mention strategies in terms of preventing the germline transmission of mitochondrial DNA mutation, and that includes the Leber's mutations. So let's now move on to part one, relating to mitochondrial antioxidants. I think the first thing to do is, as scientists, we want to look at the evidence with a clear head and check whether or not there is good evidence to use a treatment or not. And this is a systematic review of treatment for mitochondrial disease carried out by the who's who of mitochondrial medicine in the world. And the figures are very sobering because out of 1,039 publications on treatment for mitochondrial diseases, only 35 of these studies had recruited more than 5 patients. So a lot of these studies were clearly anecdotal and clearly underpowered. So all of these things have been used. Coenzyme Q10, various supplements that you can buy from your health store online, like carnitine, creatinine, L-arginine, various combinations of vitamins, right? And really they are safe. There's no doubt they are safe when used in moderation. But there is no convincing evidence that they are efficacious in mitochondrial diseases, and this includes LHON. So I'm going to talk about idebenone from Santhera Pharmaceuticals, and everyone in the audience here will have heard about the work that has been done on using idebenone for treating patients with Leber's optic neuropathy. But what I want to do is provide you with a summary of the results of these various studies. So again, this is really just to emphasize the fact that all 3 primary LHON mutations affect complex 1 subunits. And because of this, you get a reduction in energy production and increased levels of reactive oxygen species. And idebenone is a synthetic ubiquinone analog. It's like a 2nd generation of coenzyme Q10. And what it does in a nutshell, it increases the amount of energy being produced, and it also reduces the level of these toxic reactive oxygen species. So it has a dual beneficial effect. And there's been anecdotal case reports and also a large case series from Japan suggesting that it could help patients with Leber's optic neuropathy. And with the support of Santhera, we were able to put together the logistics for a randomized controlled trial to look at the efficacy and safety of idebenone in patients with Leber's optic neuropathy. And this was a collaborative effort between 3 centers, Newcastle in England, Munich in Germany, and Montreal in Canada. And in terms of the inclusion criteria, patients had to be between the age of 14 and 64. They had to have a confirmed LHON mutation, 3460, 11, 778, and 14484. And the onset of visual loss was within the last 5 years. Ideally, you would want patients with acute loss of vision, but we had to be pragmatic in terms of recruitment, so we extended to up to 5 years and then did subgroup analysis afterwards. And 85 LHON patients were successfully randomized. So what did we do in terms of treatment? The patients were randomized, blind, so neither the patient nor the doctor knew which treatment was being given, in a 2-to-1 randomization ratio. So 55 patients in the idebenone group and 30 in the placebo group. And the dose of idebenone that was used was 900 milligrams per day, so 300 milligrams 3 times daily. So patients were seen at various time points, and week 24 was the study endpoint. That's when you look at the data and you did the statistical analysis. So I'm going to show this figure here because it's relevant in terms of how the data was analyzed. So most patients with LHON, after the acute phase, will have roughly the same level of vision in both eyes. So if one eye is counting fingers, the other eye will tend to be the same, i.e. counting fingers. So in the majority of these patients, concordant mean that there was very little difference between the 2 eyes. But there were 30 patients here that had discordant visual acuity, meaning that, let me just go forward. And in this group here, there was a difference of more than 0.2 logmor. So 0.2 logmor are 2 lines on the vision chart, so quite a big difference. So our hypothesis was that these patients were at highest risk of disease progression. Essentially, the 2nd eye still had reasonably better vision, and therefore you would expect that there was a better chance of you rescuing the vision in that 2nd eye. So the important thing was the safety data, because we don't want to use any treatment which is unsafe for our patients. So idebenone was very well tolerated at the dose of 900 milligrams per day. There were no adverse drug-related reactions, which is very reassuring. And we know from other work that has been done, because idebenone has been used in other randomized controlled trials for Friedreich's ataxia and Duchenne muscular dystrophy, that even higher doses of 2,250 milligrams per day were safe. So 900 milligrams should definitely be safe. So when you do a study, you have to have outcome measures to be able to determine whether or not your drug is working. And we use several outcome measures. The most important one, of course, is vision, because that's what most people want. They want a treatment that will improve their vision. So we use various outcome measures. Best visual recovery was essentially the difference between we compared baseline and then week 24, and then we took the eye where there was the greatest degree of visual recovery. Another visual outcome measure was change in best visual acuity. So you took the best vision at baseline, the best vision at week 24, and then you took the difference for the statistical analysis. So I'm just going to show a few figures here, which I will summarize, so don't worry if these seem a bit complicated. But essentially, on the y-axis here is a change in logMAR vision. The idebenone group here is shown in orange and the placebo group in gray. And if you look at best visual recovery for the whole group, the intention to treat analysis, there was a difference of 3 letters at week 24, but this was not significant. If you look at, again, best visual recovery, because this was the primary outcome measure, but for the discordant group, there was a difference of 2 lines of vision, at least 2 lines of vision between the 2 eyes, the results were much more interesting, because if you look at the untreated and treated group, there was a big difference of 13 letters, and this was highly significant. So the treated eyes did better than the untreated eyes. The other outcome measure was change in best visual acuity. And again, here, if you look at the whole group, there was a difference of 5 letters, and this was just borderline significant. So it was enough to tell us that it is probably doing something, but at least using the whole group, it was not significant. But when you did a subgroup analysis, there was a big difference here. And this is quite interesting because in many ways what you're observing is the behavior of the better seeing eye. So in the untreated group, the vision got worse by 20 letters or more, whereas in the treated group, there was a stabilization of vision. So if you look at all these outcome measures, right, okay, for the whole group and for the subgroup of patients, all of them favored idebenone. So this is called a forest plot, but it is telling that if you look at all these outcome measures, the direction was always in favor of idebenone, but this was much more striking in the smaller subgroup of patients with discordant visual acuity. So the results were published in Brain, and the results were certainly very promising, and we took a lot of encouragement from the results that came out. But we also need to acknowledge the fact that these promising results were based on subgroup analysis, not on the primary intended outcome measure. And as part of the follow-up to Rhodos, we also collected data to see what happened after the treatment was stopped. And again, the paper was published in Brain as a letter to the editor. And long-term visual acuity data was available for 58 out of these 85 patients. And then we basically collected additional visual information. And the main observation here was, if you look at these patients, at week 24, which was the end of the study, there was a difference of 6 letters. And almost 2 years later, after the treatment was stopped, there was still a difference of, there was still a significant difference between the two. And the overall message was that the beneficial effect seemed to have persisted even after idebenone was stopped at the end of the Rhodos trial. So again, this is very encouraging data. And to put everything into perspective, Valerio Carelli's group from Bologna also published their experience of using idebenone in patients with LHON. It was a retrospective case series of a large group of patients. The slight difficulty here is that the patient had varying doses of idebenone, not the uniform 900 milligram per day that was used for the Rhodos trial. But despite the limitation of it being retrospective with different doses, it did support a visual benefit with idebenone treatment in LHON. And this is a very important conclusion from that paper, is that there was an increased likelihood of visual recovery with earlier and much more prolonged treatment. And if you look at this graph, which I've taken from Valerio's paper, the one thing that you need to remember is that patients in the Rhodos trial were treated with idebenone only for 24 weeks. And if you look at this graph here, which is the difference between people that were treated and the untreated group, you can see that as patients were followed up for longer, 10, 20, 30, 40 months, the difference between the two groups became wider. So suggesting that the longer you treat, the better in terms of the visual outcome. And the other important question that you will be asked, certainly we do get asked in clinic when we see patients that have been affected in only one eye and there is already a diagnosis of LHON, is whether idebenone can prevent second eye involvement. Unfortunately, the answer based on Valerio's paper seems to be no, because 6 patients were treated after first eye involvement. And all of them converted in the second eye with a difference between the 2 eyes of 3 to 8 months. And the other point I want to make is that there is no evidence to support the use of idebenone as a prophylactic measure in asymptomatic LHON carriers. And we can talk about this more in the Q&A session, but this is my position on this, that there is no evidence to support the use of idebenone if you're not affected. So what about regulatory approval? Santhera submitted a marketing authorization in 2011 to the European Medicine Agency. And the target population was patients presenting for treatment within 1 year of disease onset. Unfortunately, the application was rejected by the EMA, which is the European version of the FDA, in January of last year. And the main reason why they rejected the application was because of the small data set in the proposed target population, which was patients treated within 1 year of disease onset. There was only 28 of them. And if you change figures for some of these patients, this could actually change the conclusion. So they based their rejection on the small data set. So what do we do in the meantime? It's a very difficult situation to be in. If you're in Italy, like for Valerio, things are easier because idebenone can be prescribed free of charge to LHON patients. They have a special program which is funded by the National Health Service under special existing legislation for rare diseases. So Valerio has the chance of being able to prescribe idebenone for his patients. The situation in France changed at the start of the year because since January of this year, there is a temporary authorization to use idebenone for patients with Leber's optic neuropathy, and again, it's covered free of charge by the National Health Service. The rules for prescribing, the patients have to be within 1 year of disease onset. There must be a minimum treatment of 6 months, and it has to be continued until vision becomes stable. So this is the situation in France as from the start of the year. In the UK, we don't have access to idebenone. I can't prescribe it in my clinic. And in other countries where this is the case, you can get in touch with Santhera for their named patient program. And this is a slide that was provided to me courtesy of Dr. Thomas Mai from Santhera, and they've recruited more than 60 patients now in their named patient program. But for the vast majority of patients, if they want to take idebenone and they can afford to buy idebenone, a lot of patients will get it from various internet sources. And the slight caveat here is that you don't really know what dose you're getting, the purity, but this is a situation where a lot of families and patients that have been affected are desperate to get access to idebenone, so they will buy it from various internet sources. So this is the situation at this point in time for idebenone. The second mitochondrial compound I want to talk about here is Epi743 from Edison Pharma. Epi743 is a member of the vitamin E family, and it is a quinone derivative of alpha-tocopherol. Don't ask me what it is, that's the information I have been provided. But the reason why it's an interesting compound is because we know that this compound, reduced glutathione, is an important scavenger of reactive oxygen species, and this is an important element in what we think is contributing to retinal ganglion cell loss in Leber's optic neuropathy. And Epi743 is thought to protect against oxidative damage and cell death by promoting the regeneration of these reduced glutathione. And Alfredo Seydun is not here today, but he published this paper in Archives of Neurology 2 years ago on his experience of using Epi743 in 5 patients with acute LHON. And all these patients were treated quite early on, within 90 days of disease onset. And they reported a stabilization of vision in 4 out of 5 cases. And Alfredo, again, has kindly provided me with his follow-up data with the expanded data set, and some of these patients were also recruited by Valerio in Italy. And this is 2-year follow-up data on 21 patients treated with Epi743. And the bottom line is that a third of these patients experienced significant visual improvement, a third of them remained stable, and a third of them did badly, as one would predict from what we know about the natural history of Leber's optic neuropathy. So again, some very promising preliminary results. But obviously, these encouraging results need to be confirmed. And the only way to do that properly is to do a multi-center randomized controlled trial. And certainly Edison is considering setting up an RCT, and hopefully this will happen in the very near future. So the third compound I'm going to mention here is this compound Bendavia that Valerio also mentioned in his presentation from Stealth Peptides. And again, I'm not going to go into the technical detail here, but Bendavia is thought to have a strong mitochondrial protective effect by increasing the amount of energy being produced and by decreasing the level of these reactive oxygen species. And there is good safety data for the use of Bendavia in patients. There is a randomized control trial ongoing at the moment looking at whether Bendavia could be helpful in patients with acute myocardial infarctions. And Ocuvia is the topical formulation of Bendavia. And again, Stealth Peptides is looking into the logistics for setting up a multi-center randomized control trial to look at whether Ocuvia could be helpful in patients with both acute and chronic LHON. So already we can see that 5-10 years ago there was nothing in terms of potential treatment, but already there's a lot of interest from various pharmaceutical companies to look at compounds that might be helpful in reversing some of the detrimental effect that we see in LHON, and to start with small studies first, and then if it's promising, to then look into the logistics needed to do a larger randomized controlled trial. The second part of my presentation, I'm only going to cover that very briefly because Valerio has already mentioned the work that has been done on activation of mitochondrial biogenesis. But I thought because I'm covering treatment, I might as well have a few slides here, especially if people in the audience were not here this morning for the first part of this session. So there are several mysteries about Leber's optic neuropathy, and we still don't really know why only about 50% of male carriers and 10% of female carriers will lose vision. Why is there such a marked incomplete penetrance, and why is there such a marked sex bias, with male carriers being 4-5 times more likely to be affected than female carriers? And obviously what this means is that there are additional risk factors that are modulating the phenotypic expression of the primary LHON mutation. So like Valeria explained, right, you need to have the LHON mutation, but that's not enough to cause visual loss. So in terms of incomplete penetrance, this very important paper came out only this year in Brain, and it did provide a huge amount of data, very convincing data, showing that unaffected LHON carriers have higher mitochondrial DNA copy number compared with affected LHON carriers. So essentially what's happening here is that you have a better compensatory mechanism in unaffected LHON carriers. And in terms of the marked sex bias, as Valeria has mentioned already, the obvious reason why there's a difference between male and female LHON carriers could be due to female hormones, because that's one of the things that is different between men and women. Women before the menopause have high levels of these of estrogens floating around in their body. So with Carla Giordano, who is based in Rome, they published this paper showing very clearly that estrogens could ameliorate the mitochondrial defect in cell lines that had been derived from patients with Leber's optic neuropathy. And this is really relevant because if you look at, this is just a cross-section of the retina, which is the image sensing layer at the back of the eye. And these retinal ganglion cells have very high levels of estrogen receptors. So how do you go about to try and prove whether higher estrogen levels could protect female LHON carriers from visual failure? So what Carla Giordano and her team did was to basically look at controls from healthy people and compare them with the three mutations, 3460, 11778, and 14484. And if you look at this graph here, simply on the y-axis here is the percentage of cell death, right? And if you look at the controls, there is a low level of cell death, whereas if you look at the LHON cell lines here, there's a very high level of cell death. And what was really relevant is that when you actually supplemented these cells with estrogens, the amount of viable cells increased. It was still quite a high level, nearly 50%, but significantly less than when there was nothing. So this provided some convincing data that estrogen supplementation could protect cells carrying the Leber's mutation against cell death. And the obvious conclusion of that paper was whether there would be some potential treatment in the future that you could come up with that would have estrogen-like properties without the side effects. And these slides here have been kindly provided to me by Carla Giordano, who did this work funded by a grant from UMDF. And I'm only going to briefly mention, because Valerio has already discussed the main findings from this study, that essentially, if you look again here at this graph, on the y-axis here, you have the percentage of viable cells, so the percentage of cells that were still living in these tissue culture media. So for the wild type, it was about 35%, and for the Labor's cell line, it was significantly reduced, about 15%. And what Carla Giordano and her team did, she basically used varying combinations of these estrogen molecules, and also a specific combination of GD and EQ. And what she found, which is very interesting, is that with this combination of estrogen molecules, there was an increase in the amount of viable cells, coming up closer to what you found in normal control cell lines. And therefore, also what she found in her experiments was that this combination of estrogen had a beneficial boost on mitochondrial DNA replication. So this is basically replicating what hopefully that we can manage is by using a combination of these estrogen molecules, you could increase mitochondrial DNA copy number and therefore protect unaffected LHON carriers against visual loss. So the experimental work is carrying on in vitro, and I'm sure we'll be hearing more about this area of research in the years to come. So third part, what about unproven therapies that your patients might come across by using Google or various other search engines on the internet? Well, the first thing I'm going to mention is hyperbaric oxygen therapy. Because very recently in the Irish press, there was this report of this young boy here who lost vision at the age of 12. He started treatment at the age of 14 with hyperbaric oxygen therapy. And by the age of 16, his vision had improved enough for him to be able to drive, which is great for that young boy. But I think the one thing that we need to keep in mind is that because he lost vision at quite a young age, and we know that visual loss at a young age is a good prognostic factor. So the younger you are when you lose vision, the better your chance of recovering significant amount of vision. So his visual recovery could be due to the natural history, as opposed to anything to do with hyperbaric oxygen treatment. So why are some people promoting the use of hyperbaric oxygen therapy in patients with LHON? Well, the main rationale is that you are increasing the amount of oxygen that is getting to your retinal ganglion cells. And by increasing the amount of oxygen, you're increasing the amount of ATP being produced. Okay, which is not bad as an argument. But the evidence is very slim. And what people are doing, they are extrapolating this from other optic nerve disorders like radiation-induced optic neuropathy. But even for radiation-induced optic neuropathy, hyperbaric oxygen therapy is very controversial. And for LHON, you could make the reverse argument that actually hyperbaric oxygen therapy could be harmful, because if you have high levels of oxygen floating in your cell, this could actually increase the amount of reactive oxygen species that are being produced, and this could therefore be detrimental to your retinal ganglion cells. So my personal feeling is there is no evidence that it works. There's possible reasons why it could be detrimental, and I personally don't promote the use of hyperbaric oxygen therapy for patients with LHON if they ask me what is my personal feeling about it. So what about stem cells? This is a very tricky area, because if you look, stem cells are always a sexy topic because the media always report research relating to stem cells, and there's a lot of good work being done at the moment about how stem cell could be used to understand the mechanisms leading to retinal ganglion cell loss in Leber's optic neuropathy. And there's also the potential for using stem cells to replace diseased organs. But it's still at an early stage. And certainly for Leber's optic neuropathy, there's very little evidence at this point in time that there is any credible treatment out there that can help your patient. Unfortunately, if you put LHON and stem cell in Google, you will come up with a couple of examples of people traveling to various parts of the world to receive various forms of stem cell injection. I'm not sure what they are getting injected, in what condition, and it could be, essentially having saline injected into their spinal cord, but, it's a very tricky area. And I think most people in this audience will agree that the treatment being promoted is pretty dodgy in terms of the science. It's mostly unregulated. It's expensive, $20,000 US for one cycle of treatment or more. And it's certainly not limited to China. I think China gets a lot of bad press about stem cell clinics in various parts of China, but there are countries in Eastern Europe or even centers here in the US who are promoting stem cell treatment for Leber's optic neuropathy with very little evidence base to support it. So my personal view is I do warn my patients about various stem cell scams on the internet. And unless there's going to be a proper study done by an established research group in a major center with a good evidence base, and we know it's going to be done in a very safe and regulated fashion, I think anything out there is being done purely for commercial reason. So this is my strong view on this, and I'm sure Valerie will agree with me on this. The fourth part of my presentation is on gene therapy. And this is an area which is very exciting now because things are moving fast, and we hope that this will make a big difference to patients' quality of life if these studies are found to be positive. And the first thing that most people will think about in terms of mitochondrial gene therapy is why we don't simply replace the defective mitochondrial gene. So people are working on this, but we need to remember that this is very difficult because the mitochondrial genome is protected by two membranes, an outer membrane and an inner membrane. So it makes things twice as hard. So a way around this is this treatment called allotopic gene expression. And a lot of people in the audience will have heard of this. So what is allotopic gene expressions? If we can't introduce the gene directly into the mitochondrial compartment, what you can do is introduce the mitochondrial gene into the nuclear genome. The protein gets produced, and the protein has a special tag attached to it, which allows it to be imported into the mitochondrial compartment. So that's a way of bypassing this difficulty of cutting across two membranes. And over the years, two groups have really pioneered this technique of allotopic gene expression. A group in Paris, led by Marisol Corral-Debrinsky and José Sahel, and a group of John Guy at Bascom-Palmer. And I'm not going to summarize all the data out there, but they've published several papers over the years showing that retinal ganglion cells can be rescued with preservation of visual function. So based on this on these data, both in vitro and in vivo in animal models, what they are doing now is moving forward with early stages of clinical trials for patients. So the Paris group, in collaboration with Gencyte and with the 15 National Eye Hospital in Paris, have started the first phase of their gene therapy trials. And the first phase will be really about the safety of using this gene vector when injected in only one eye of patients with chronic LHON. And the first patient was injected in February of this year, and recruitment is ongoing in Paris to determine whether this vector is safe. And if the vector is found to be safe, then of course there will be a second phase in terms of looking at whether they can use this vector to rescue vision in patients affected with LHON. And in parallel, John Guy's group in Bascom-Palmer have secured funding from NIH, and they will also be starting recruitment soon into their gene therapy trial. So there's absolutely no doubt that this is an important research milestone in terms of treatment for Leber's optic neuropathy. And the launch of these clinical trials will provide a lot of data. But we also need to be cautiously optimistic because there's a lot of experimental data, but really we will only know when patients are treated whether it's going to be efficacious. And also we need to collect additional data in terms of long-term safety, because safety is paramount to everything that we do. So these studies, both in Paris and in Bascom-Palmer, will provide a lot of information on gene therapy for Leber's optic neuropathy. So the final part of my presentation, because you might be getting bored with me already, is about preventing germline transmission for mitochondrial DNA mutation. It is a really exciting area of research that is moving very quickly, at least in the UK where I come from. And we all know that the mitochondrial genome is a double-stranded circular molecule. It's quite small, and it shows strict maternal inheritance. So 3 years ago, this was big news in the media and was reported by all the media outlets all across the world. The so-called free-parent embryo. Not the best term to describe the technique, but that's what the media does. They latch onto a term, and the term they wanted to use is free-parent embryo. But it is looking to a very important question about how can we prevent the maternal transmission of mitochondrial DNA mutation to the next generation. And this is very important for an affected female carriers who might want to have children later on. And this is a major research objective of the Newcastle Mitochondrial Group 1 base. And the current director is Doug Turnbull, who has been doing an amazing amount of work on the basic science relating to this new IVF technique, and also trying to promote the use of this technique to help patients with mitochondrial disorders. So what is the science behind this potentially revolutionary technique? Because it is, revolutionary in terms of what they plan to achieve with it. So again, there's been several very important papers over the past 4 to 5 years on preventing transmission of mitochondrial DNA mutation. I'm just mentioning two here, one from the Newcastle group and the other one from a group in Oregon led by Shukrat Mitalipov, who is also looking at an IVF technique, not exactly the same, but they want to achieve the same aim. And these two techniques are called pro-nuclear transfer, that's the one which is being studied in Newcastle, and the technique in Oregon is called multiple spindle transfer. I'm not going to go over the technique, but I'm just going to illustrate what we are trying to achieve with this technique. So in pro-nuclear transfer, you have a patient couple here where you have the 40 mitochondria, and after fertilization, the nucleus is removed. On the other side, you have a healthy female donor who has healthy mitochondria. You remove the nucleus, and then you combine the two together. So the fertilized nucleus is put inside this donor egg from this woman here. And then it goes through the normal process of IVF. And then this is implanted in potentially in the mother. So as for most new techniques, there's a lot of debate, both for and against. And there are a lot of reasons why people are against it, ethical, moral, religious. And that's the reason why, over the past 2 years, there's been a lot of consultation in the UK about whether or not it is the right thing to do. So last year, the UK government had a public consultation that allowed clinicians, scientists, patients, various groups to come together to give their views about whether or not it should be used in patients with mitochondrial disease. And I'm just going to summarize the conclusion here from the Nuffield Council of Bioethics. So their take on it is that this novel technique, if proven to be acceptably safe and effective as treatment, it would be ethical for families to use them. So it's positive backing of this technique. But I think we also need to remember that we still need a lot more information about the safety of this technique, because in the papers that have been published, a proportion of manipulated zygote showed abnormal development in vitro. And additional research is being done now to look at the safety of this IVF technique in higher primates. And there's good evidence that this technique will be safe. So the same discussion is happening here across the pond in the US. And the FDA has recently convened a 2-day advisory panel in February of this year. And this guy, Ivan Snyder, is the chairman of this committee. So at least here in the US, they're a bit more cautious. And from his quote here, the overall conclusion of the panel was that there was probably not enough data to conclusively move on to human trials. So they are still wanting more information in terms of the safety of this technique. In the UK, things are moving faster, and in February of this year, the UK government has announced the decision, has basically started the process to draft regulation. And if the regulation is drafted, then it will have to be debated in Parliament, and then people have to vote. So there's still a long way to go, but certainly things are moving much faster in the UK compared to the US. And just as I'm finishing, I think it's important to mention about the situation for unaffected LHON carriers. Because genetic counseling remains very challenging, because we still are unable to say with any great accuracy whether someone is going to lose vision or when they are going to lose vision. Of course, we can base the risk on age. If you're older than 50, your risk is much lower. If you're male, your risk is 5 times higher. But what does it mean at the individual level? It's an imperfect science, and we're all faced with this in clinic. Then there is no evidence to support any form of prophylactic treatment in LHON. But the one thing that we need to stress to everyone that we see in clinic, and it's just common sense, is the need to have a healthy diet, not to smoke, absolutely not to, you must not smoke, because there's very good evidence that if you smoke and you're a LHON carrier, instead of having a 50% risk of losing vision, your risk is 100%. So smoking, if you're smoking, you're increasing your risk of losing vision by 100%. About drinking, I don't have a complete ban on it, but I think people need to be sensible. If they're going to drink, it's one drink, occasional one, no binge drinking, you're not going to get drunk out of it. And also, I think it's sensible to avoid certain antibiotics, for example, ethambutol, which is known to have a detrimental effect on mitochondrial function. So just to summarize here, because it's been quite a long stretch from when I started, LHON is an important cause of mitochondrial blindness among young adults. You absolutely need to give hope to your patient because things are moving in the right direction. But you must also be frank about the current limited treatment options and also warn them about treatments that might not work. For example, dodgy stem cell treatment that you can get access to on the internet. And it's great to be here because when I started research in LHON, that was back in 2000, it was really, everything was about the genetics, the basic science, nothing much about treatment. But now, that's where a lot of the research is going. How do we translate things from the bench to the bedside? And I think this is going to be an exciting area of translational research. And finally, I think the reason why we're here and the reason why we're putting all this effort together, it's very clear that any treatment that is found to be potentially beneficial for labours will have to be verified in a properly powered randomized controlled trial. And that's where multi-center collaboration will be very important. And I'm very lucky to count among my friends people like Valerio Carelli, Alfredo Seydoux, and Nancy Newman, and we are all there to work together to make these trials possible. So I just want to show this picture here. It's only part of the mitochondrial group, but it really gives an idea about the great team I have the chance to work with, especially Patrick Chinnery, who's my good friend and mentor, and he's really helped me over the years, and he's also has a major interest in Leber's optic neuropathy. And also the good thing about doing research is that you get the chance to meet and work with a lot of people. You have Valerio Carelli here, and if you know about your beer, this is Newcastle Brown Ale here, right? And Chiara also is here in the audience, and all these people are really working very hard to find treatment options for patients with Leber's optic neuropathy. So thank you very much.